All right, welcome
Right.
back. And we have Ali Biparva here with us today from Crichton International. Ali, thank you for joining us all the way from Vancouver.
Hi, Paul. How are you? Thank you for having me.
Yeah, we're doing good. We finally got some good weather here in Philadelphia. You were just mentioning before this, we hit record that you're now in rainy season in Vancouver, but isn't rain? It doesn't it rain all the time in Vancouver?
No, actually, we have some good sunny days in Vancouver. Look like almost 3 months. But by surprise, in this summer, we have more rain in the last couple weeks.
Oh man! So every time I've been to Seattle, it constantly rains, and when we are in Seattle, we sometimes try to go see our friends that are in Vancouver. And I tell anybody that ever asks me that I've been all over the world, I've been a lot of places, a lot of places in the United States, and people ask me sometimes, "What's your favorite city that you've been to outside the United States?" And it's cheating a little bit to say a city in Canada, but the God's honest truth is Vancouver is my favorite city I've ever been to that is outside the United States. I think you're lucky to live there. How long have you lived there?
Actually, more than 24 years.
Wow. And
Yes,
how many of those with Crichton?
more than 18 years.
18 years with
Yes,
Crichton.
yes.
Wow. So tell us a little bit about your background. So you've been with Crichton for 18 years, but how did you get to this point? What got you interested in cement and concrete?
Actually, that's a great question. First, I grew up in the family that was in construction, and so that's why my first background was mechanical engineering. I get to the mechanical engineering. At the same time, I work in the construction with the family. But when I moved to the Canada in 2000, I started my grad school at the UBC, University of British Columbia, on the material field. And so that was the part that I become more and more interested in concrete. And I really became interested in the waterproofing because my grad thesis was about the concrete waterproofing. So that was the reason I started my, building equipment to test the concrete waterproofing under stress. And after graduation, I got the offer from Crichton in 2006, and I joined Crichton. And I'm working in Crichton since then.
Oh, that's great. So back in the early 2000s, mid 2000s, what was the waterproofing admixtures like? Were they all integral? Were they only topical? What was like the state of waterproofing back then?
Actually, just to be honest with you, when I was at the university and I just even studied at the university, not many people talk about the integral waterproofing or admixture that can be added to the concrete. So that's why my knowledge, based on my study at the university about Crichton or even companies look like Crichton, was very, very limited or no. So the first time I heard about the concrete waterproofing admixture, it was a time that that the previous research and developer of the Crichton International visited our campus. And when she talked about Crichton's solution, that it was the first time, and I become look like aware that we can improve the concrete uh, properties, reduce the permeability by adding some additive. So, and after that, after graduation, I joined Crichton. And even if based on your question, if I want to explain, because when I joined in 2006, I started to visit different countries. For example, the first trip I went, it was 2007. And I went to some country in the, Middle East. And whenever I talk about integral waterproofing, lots of people just they look at me, what are you talking about? At that time, not many people knows about this solution is available, and not many people even use it. So, and after that, the first part of our job was education of the people that in addition to using that material as a membrane that was about traditional method, you'll be able to reduce the permeability of the concrete by using the additive. And even at that time, the number of companies that they have this solution was very, very limited, back to 2006, 2007.
Yeah, well, so we'll get to the membranes and
Yeah,
different solutions
yeah.
in just a minute. I do want to touch on something there that you got out and you started traveling and you were talking to folks. So what folks were you talking to? Architects, engineers, contractors? Who was it that you were having these discussions with?
Actually, it's a very good question because even from that time until now, I have to deal with everybody from, the owners, from the consulting company, architects, contractors, everybody they should know in the sometime about our solution and for them somehow the effects they work. For example, if you are talking about the architects, as an architect, you need to know what's the solution is available because it affects on your design. As an owner, it's really good to know what solution is available because it affects on the budget, affects on the speed of the work. For the contractor, again, it's important to know which solution they are using. So that's why if you are asking about who is our target of audience, since I, that travel to the different places, I can say almost everybody, all of the stakeholders from the owner to the contractor, subcontractor, that architects, everybody.
So before we dive into like the technical side of it from concrete hydration standpoint and then concrete durability and the different things that you're looking for and trying to improve, I want to take a step back. If you'll humor me, could you walk me through like how you acquire a project or a client? Like how does that work when you're trying to get this waterproofing admixture, whichever type you're trying to get, whichever solution is the right solution for a project? How on earth are you getting that, through completion and into a project?
Actually, that's because for different project at the different stages. For example, part of our approach is education of the people, look like education of group of the people, look like bringing some consultant or contractor in the one room. Too many people educate them that this solution is available, and whenever they are seeing this solution is match their requirement, then they come to us, ask us for more information about our solution, what's the difference between our solution and alternative. That's a one way, that education of the group of the people. Another way is through our sales team, because sales team they are looking for in which type of the project it match with our products, and after that, in that stage, sometimes they present by themselves. Sometimes we go along with them to doing the presentation, and that because in the early stages, sometimes the question and answer is not that much technical, but if they convince in that level, the next level is they need a little bit more depth information. Then we go there as a technical service, and then we provide additional information.
Okay, interesting. So we're similar in that way with Actigel. Not always working with architects and engineers, but the contractors and the concrete producers, and do a similar function. So
Exactly.
I'm always interested to hear how other companies are succeeding and what really is often a conservative industry that is sometimes scared to change and sometimes not. So I really, Joey and I applaud you for going out there right out of school and immediately getting in front of people and trying to talk to them about something they've never heard of. Like you said, integral. What is that? What does that mean? They're probably looking at you with blank stares on their face. Am I correct in that?
Yes, absolutely. And even that, as I mentioned initially, because this material regarding integral waterproofing is not a part of education at the school, is not a part of material that the people learn at the school. So that's why is that something is missing, and then you need to the first step is become education. And exactly as you mentioned, as I mentioned that when I went to the most of the countries that never heard about our product, just as is it really is possible that I remove this protection and just consider concrete as a waterproof. So even for them, it was a surprise. And then that we start to giving them. So because honestly, the concept of integral waterproofing is not new. Look like our company started in 1967, long time ago. And for the first project that they use our product, it was as an admixture. It was in 1980s in Seattle. So that's why they use our product for many years. So that's why you have to consider that this is not a new solution, but still for some market still is new. So that's why they need some education.
Well, I think lots of us needs education, and that's why you don't just do education for companies. I saw where you've got like your ACI talks and that have been
Yeah,
recorded and distributed. So,
yeah,
thank you for making that available to everyone.
yeah,
And, that's part of the reason why we're having this conversation here is Joey and I are in the thick of this, in the thick of the industry, out on job sites all the time. And he and I are not experts and crystalline waterproofing, integral waterproofing, the other types of products that you have, and that I want to get into some of that in just a minute. But just to step back for a second and bring the audience up to speed where we're at right now. We were talking to you about coming on the podcast, and it's interesting because this is an area that we don't have a lot of experience in and a lot of knowledge in. That's our favorite kind of guest to bring on,
yeah,
someone that can educate us because we're going to ask the questions that our audience would be asking. And so we kind of go on this journey together. So to get where we're at right now in this conversation, we had an opportunity to not just look at your website, but read some papers and read some articles that got published. Congratulations on some of those, by the way. And what I what I took away from it personally is that from your point of view, and this is where I want you to correct me if I'm wrong and expound if I'm right. From your point of view, water coming into hardened concrete is causing three main problems. The first problem was corrosion of steel reinforcement. The second problem was alkali silica reaction, ASR. And the third problem was alkali aggregate reaction, AAR. And all three of those problems have a solution. And it's been your life's work up to this point to research and say, yeah, we do have a solution. And then you've gone around and told the world about it. First, am I correct in that synopsis? And if not, correct me. And if yes, talk to us about waterproofing concrete and what that really looks like, what that really means.
yeah, yeah. Actually, it's great because I'm thinking you're referring to the one of the paper that we talking about the combined system, and we're talking about the possible effects of the water on a existing structure. So look like the water, they can cause this or that. But if I want to refer to the one of the code that I used in, that's my presentation even at the ACI and in some paper, we call it water is the best friend and worst enemy for concrete structure. How we can consider as a best friend, because water is required for um, making the concrete, because initially we adding the aggregate, cement, water to mix it together. Without water we cannot make the concrete anyway. So that's why at this stage is the best friend. So if you are adding enough, and after that, after placement of the concrete, still is the best friend because concrete need to be cured. So up to that stage is the best friend. But whenever concrete is get hard after curing, they completely change from the friend to enemy. So that's why you call it concrete is the worst enemy. And the reason I call it worst enemy, because if you look at all of the main mechanism, and that you list talk about some of them, look like corrosion, chemical attack, AAR and ASR is very similar. That's from the same thing, from the same family. Freestyle and all, the sulfate attack. If you look at all of the mechanism, they attack concrete structures, they need the water. And without the water, there is no corrosion. Without the water, there is no ASR. Without the water, there is no freestyle. Without the water, there is no sulfate attack. So that's why if we be able to protect our structure against water ingress inside of the concrete, we will able to protect them. So, and that's a concept that whenever we are talking about the waterproofing, we need waterproofing for two main purposes. One of them is for serviceability. So it look like if you have the basement, you don't want the water get to the basement. If you have the water tank, you don't want water leave the water tank. So that's why the one part is serviceability. But another part, which is even more important than in some cases serviceability, is the durability. Because whenever water penetrate inside of the concrete with the ASR, corrosion, and other factors, they cause some damage to the structure, the effects on the service life of the structure, they increase their requirement for maintenance or repair. And this means make a structure less and less durable. So that's why there is a tight correlation between waterproofing, durability, and these days, something has become very critical worldwide. People, we are talking about sustainability. We are looking for more sustainable structure. We want to be more green. We want to consume less energy. And whenever we be able to increase the service life of our structure, at the end, we have more sustainable structure. So that's how we can correlate permeability, durability, and sustainability to each other.
Well said. I want to jump into corrosion first.
Okay.
I think this is the one that is easiest to talk about because it's the one we can actually see.
Yeah.
You can drive underneath the bridge deck and you can
Yeah.
see
Yeah.
that the steel reinforcement has corroded. It seems to me that people try to tackle this problem from a lot of different angles. You guys are coming at it from densifying the concrete. I've seen people that are, the industry tried to do epoxy coated rebar. It doesn't seem to work. People don't like that. People trying to get rid of reinforcing steel and put macro fibers in it. You know, what is it about all of these solutions that keeps you coming back to the waterproofing admixture?
Actually, there is a one thing. The first we have to ask ourselves why corrosion is very critical that everybody looking for a solution for it. So that's why I can say everybody from different view, they want to say I can protect corrosion by using cathodic protection. I can, that protect the rebar by, that improving the rebar type or just coating the rebar or just other solution. One of the main reason that because if you look at the whole, that's deterioration mechanism that they affect concrete structure, corrosion is on the top. Even in some countries, that third quarter of the damage to the concrete structure coming from the corrosion. So that's why corrosion by itself has a huge effects on the in the worldwide, that industry, and in the worldwide, construction, because then when the structure is corroded, they damage, then they have to come with the, that first repair or just completely make a new one. So that's why the first one of the region is corrosion has a huge effects on the economy worldwide. That's one thing. So regarding to your question about how we can protect and why we have a different solution or different, that solution for this problem, we have to consider one point that exactly as you mentioned, there is a different way or different view of protection of the concrete. But one thing that we look at the Crichton and we consider as a how Crichton they can control the corrosion, because we are looking for element that required for corrosion. Because the element that required for corrosion is one of them is water, another one is oxygen. So, and when we are saying that whenever we be able to minimize this factor that it is required for corrosion, then we can control the corrosion. Because when there is no water, there is no corrosion. Or when there is less, water they can penetrate, or when there is a more resistance against water penetration, the availability of the chloride they reach to the rebar is become less. So that's why initially, even corrosion initiation, they takes much longer. And after initiation, if you're having the propagation of the corrosion, just we can slow down that one. So that's why using the product like Crichton that they can assist on protecting of the rebar by reducing the water is a solution that they can not only delay the initiation, but in addition, slow down the propagation as well.
How does that work? You're just densifying the concrete to restrict the bleed channels, so there's you don't have those capillary channels for the water to later migrate in through. Is something else happening?
Actually, that's a very good question because the word of densifying, is using a lot because one thing that we keep talking about the concrete, typically if you have a more densified concrete, it means we have a less channel for passing of the water. I think this word is accurate mostly at the laboratory, but not in the real life. Because in many cases, you can have a very dense concrete, But as soon as the concrete is cracked, it means concrete has no protection and rebar has no protection. Just I want to give you one example. If you are using the microsilica in the concrete, you can densify the concrete. But on the other hand, if you are, that's something is one of the project I seen by myself. So you can have a very good mix design with the microsilica in the laboratory is a very dense good concrete. But whenever you take it to the real life, when you place the concrete and you know that using the microsilica, just they increase the chance of cracking. So that's why if your concrete does not cure properly, so you have a dense concrete with cracks. So that's why corrosion, they can happen again. But the way that Crichton is working, that our product, when we are adding to the concrete, they act as a catalyst material. And in present of the water and cement, because it's a hydrophilic material, so we are saying we are fighting fire with fire. Here we are saying we are fighting water with water as a hydrophilic system. So in this case, you know that initially they use the water, and the beauty of that, since it's a catalyst material, during this chemical reaction does not consume. So that's why remain on the concrete for the whole life of the structure. And as a result of this, that reaction, they make some needle-shaped crystals, very, very fine needle-shaped crystals. And the beauty of these needle-shaped crystals is because it's much smaller and finer than typical cement hydration product from one way. And since it's a needle shape, they can interlock in each other. And since they interlock in each other, they can, make a good resistance on any pathway in the concrete. That's the first part. But something that is more critical and has been, studied recently and even in the past in a different way is the self-sealing properties of our product. Because whenever you are adding our product to the concrete, they can help to self-seal any minor crack or a small crack in the concrete, and a combination of crystallization plus improving the self-sealing of the concrete, they make a good resistance against water penetration. Even we have lots of studies that they shows based on the different mix, 60%, 70% of reduction on the permeability. And I'm sorry, and that one they reduce the presence of the water at the rebar and they reduce the corrosion.
We'll try to link that. There's a paper that was published in 2021 in the journal Materials, where you were a co-author on that paper, and it has a good explanation of some of these effects that you're describing, including the self-sealing. And I specifically am interested in that term, self-sealing or self-healing concrete. I feel like I've seen that in some of the publications. What could you go just a little further into what that mechanism is? And I'm asking out of pure curiosity, because if people see the photo in that white paper, you see cracks in a concrete, and then at some time period later, and I don't want you to tell me how long that typically takes and what that mechanism is. At some time period later, the cracks are gone. They're completely gone. And I would love to know what the magic is behind that, please.
Yeah, and actually, if I want to explain about the self-healing, because there is a two terms, self-healing and self-healing, is a slightly difference between that I'm going to explain. But if I want to explain about the self-sealing properties of the concrete, it's very similar to the concept of the paper cut for the body. For example, if we have a paper cut and we have a small, scratch, so we have some bleeding. But body is able to heal itself and stop the bleeding by itself without additional help. In the same way, if we have a minor small crack in the concrete and water passing through the crack and we have a small flow of the water, the flow of the water will be reduced, and even in the some condition reduce until completely stop. And this happened because of when the water passed through the concrete, there is a different mechanism. They help to self-seal concrete. Is one of them additional hydration, swelling, debris. And when you are looking at all of these, plus when you are adding our product, because typically concrete by itself is able to heal cracks up to 0.2 millimeters. It's very, that hair cracks, small cracks. But whenever you are adding our product to the mix, our product, they can enhance these properties, and even bigger cracks, even up to zero point 0.5, or even in some cases we have seen up to 0.6, they can be healed by itself, sealed by itself. So in the past, we mostly, that tested our product for self-sealing. So self-sealing is stopping the leakage or stopping the bleeding, something like that. But what's the difference between the self-sealing and self-healing? Because these two terms sometimes, we are using this time or this one or that one. The difference between self-healing and self-sealing, when you're having the self-healing, some of the mechanical properties will be retained, because whenever you have a crack in the concrete, the strength will be reduced. But whenever we have a healing, it means some of the reduction on strength will be back. And the paper that you are referring has been published based on the study that has been done at the University of Ottawa. And in that study, not only they test the healing, the sealing, they test the healing as well. And they show us adding our product, they improve self-sealing and self-healing, both of them.
And so there's a minor crack, and the water comes in, and what is the mechanism that allows it to seal or heal itself back up? What's going on there?
Actually, can say for typical concrete, there's a four main mechanism. Is one of them is additional hydration, because you have a crack, water is coming, you have unhydrated cement, and you have a hydration. That's one of the mechanism. And as you know, the product of the cement hydration is the volume is bigger than regular cement particles. That's one of them. Another one, when water is coming, they cause swelling of the hydration product. That's another mechanism. Another mechanism is because we have a CO2 is coming with the water, and then they cause calcium carbonate. They can be generated inside of the cracks. That's another mechanism. And the final mechanism is water. They can bring some debris, small particles with itself, that inside they can make some bridges and they stop the water. So this is the four main mechanism on untreated concrete. But whenever we are adding our product as a crystalline admixture inside of the concrete, we are adding the fifth mechanism. So that's why, in addition to these four mechanisms, we have the fifth mechanism, which is a crystalline, this small needle-shaped crystal, that addition to the four, this fifth, they enhance the self-sealing properties of the concrete. And just for your information, that's when I started working at Crichton in 2007, we started doing some research to making the equipment or system to be able to check the self-sealing. At that time, no test was available. And in 2010, with the help of Dr. Gupta from the British Columbia Institute of Technology, we developed a method, which is patented method, for checking the self-sealing of the concrete. So that's something that we developed, and we published many papers. If you look at that some of my previous publication include information about the testing methods and in addition the results.
Yeah, I saw even in the 2021 paper that I referenced, there were ASTMs I'd never heard of. So yeah. I got my manuals. You can see them, one of them on the shelf right there. The other one's down there, because I had it open reviewing the ASTMs, because I had never heard of them. I didn't know what they were, and I was like, all right, let me figure out what they were doing here, and apparatuses I'd never seen and tests I'd never heard of. So I like getting introduced to new things. That was really nice. Let me ask. Sorry, I want to make sure I'm understanding correctly. Your fifth method of self-sealing, the first four, the concrete typically or nature in some way can handle on its own. The fifth one is coming from a product that Crichton would make, and that crystalline waterproofing admixture, those needle-shaped crystals that you mentioned, are they already present in that crack and helping the other four mechanisms, or when the water comes in, you're now forming new crystals that didn't exist already? What's happening?
Thank you for this question, because I think they can make it more clear. Because The concept of the crystallization for our product is very similar to the concept of hydration. So that's why whenever is water is coming and they can cause some unhydrated cement to hydrate it and makes hydrated products, exactly at the same concept, whenever is water is coming, this new crystal, they start to grow. Maybe they already have some from the past when the water was present. So that's why we call it, for example, if the water is coming, we have more crystals grow and stop the water. But in the future, if we have another post cracking, if the pressure increase or even if we have more load and the crack is open slightly, as soon as the water is coming, this reaction will be a start again. So that's why we are saying our product, they can sit dormant in the concrete and they can restart to making crystals whenever is needed from day one until the end of the service life.
So as we're talking about waterproofing with this type of admixture, the most basic thing people are doing is just putting down a membrane.
Yeah.
Can you just walk some of our audience that might not be familiar with what the membranes are, how they're used, and are they actually adequate? Is that old school technology? Should we still be using them? Just sort of educate us here on this call as well, like about these membranes.
Honestly, this topic by itself is maybe another 1 hour discussion, but if I wants to go very quickly through it, because whenever we look at that the method for protecting a structure against water, that penetration, we can divide them to the two main groups. One of them is look like making a barrier against water penetration. So you have a structure, you are making impermeable material, we call it external system or membrane system, that those membrane system, they will be applied as a look like spray application or as a look like other type of the coating or the sheet membrane system. And all of us, honestly, we have seen that is a black material you are applying. They use it below grade, above grade. So in many cases, I said the concept of the membrane as a concept, I think is a good concept because I said I have an impermeable material. When I'm putting that one, I'm not allowing the water touch my concrete. So when it doesn't touch the concrete, they cannot pass through the concrete. So that's why there is no problem on serviceability and there is no problem for the durability. So the concept is great, but we have to consider some factors about the membrane or that material they are protecting a structure. One thing that we have to consider about the membrane and their limitation is the first one, which is very critical, is accessibility. So whenever, especially for below grade structure, for example, for basement, whenever you are putting the membrane and you backfill, membrane is not accessible. So in this case, during the life of a structure, whenever the membrane fail for any reason that I explained some of them, in that time, that's typically membrane is not accessible for repair. For example, in the roof, if you are talking about below grade or above grade application, for the roof, it's much, much better because it's accessible. You can go and you can repair it. But for the below grade structure, inaccessibility of the membrane is one of their limitation. Another limitation, that's why you ask them about the old school or traditional, we call them as well. So that's a point that the membrane has been used for many years and still is using in many places in the world. But something that we have to consider, for example, if we have a one basement structure and even if the membrane failed, when there is a room, you can remove the backfilling, even you can do some repair. But think about our new structures. Look at the downtown of your city or Vancouver or other major city. You have a 4 or 5 basement below grade. All of the structure are very close to each other. It means the membrane is not accessible at all for the whole life. That's one thing. Another requirement that we have these days is a service life. So in many cases, for sure, you heard about a structure that the service life is 75 years, 100, or even 100 years plus. So whenever you look at this, you will see that membrane is not accessible and the requirement is 100 years. So now we have to see is the life of the membranes they can match with the life of the structure? Yes or no?
I'm
That's
gonna
the
get.
question.
Yeah, I don't know. Actually, I have a quick question.
Yeah.
So 100 year service life is required. Who does that fall on in the building of that project?
Actually, something is a requirement from the owner. It look like they require the building to be designed for 100 years.
Yes, because if it didn't, let's say it didn't last 100 years,
Yeah,
and it did fail, and it failed due to water ingress that ultimately corroded it and tore it to pieces, and we had
yeah.
an awful, awful thing that we're just hypothetically making up here. Um, is somebody signed on the dotted line for that thing being 100 year life? Is that the owner who's ultimately responsible? Is he trying to turn that back on the GC? Who's ultimately responsible for that 100 year life?
Actually, for example, typically for, as you know, for most of the cases, it depend on the condition countries. For some countries, the contractor is responsible for 5 years after they hand over the whole project. In some countries, 10 years. After that, they hand over to the owner or strata. So in this case, typically, in many cases, if the membrane right type of the membrane used properly and applied properly, it doesn't fail in the first 5 to 10 years. And whenever something happen, is the time that is on the shoulder of the owner. That's a typical thing. But in addition, we have to consider, even I have seen some major project in the world, that that huge project, and I can say, if I tell people, they completely know what's the project, but the membrane failed even before occupation, at initial stage.
Oh
So
gosh.
I'm not saying this happen every time, everywhere, but that's something happen a lot in the world. So, and one thing I want to just, that talk about the membrane limitation as well. And honestly, I have seen by myself at the different places, whenever you are using a product and material that they need the application, overall, we are bringing another factors on the performance, and that's a application. And that application is really depends on who is applying the material. Is they already educated? They knows how they apply it. Are they applying properly? So that's another factors that we have to consider. In many cases, the failure happen is not just because of the material by itself, it's because of the form of the application. So that's why if you look at the lots of standards, when they are talking about the membrane and the limitation, there is a difference between the laboratory result and actual performance and the real life, because you are adding another factor, which is the application of the material.
Oh yeah, we talk about that all the time on this podcast. Labcrete versus realcrete,
Right.
and in this case, it's the same, but it's doing with the application of a membrane. We, oh my gosh, I don't know. I think we've probably mentioned that with half the guests that have been on this show.
Yeah.
One of the things I thought that was interesting about some of the research that I did before we came on here, and I have a quick before I get into that, I have a quick yes or no question for you. When we're talking about crystalline waterproofing admixtures, do you refer to them as CWAs the way we might say VMA, or is that?
Actually, honestly, that's a part that I mentioned. Unfortunately, there is a different way that they just abbreviated. Some people, even in some places, they called crystalline waterproofing admixture. They call CWA. On some paper, in some cases, for example, crystalline waterproofing admixture or waterproofing admixture, they call WA. So honestly, that's a term that is not properly used everywhere. So, and that's why, if you want to look, you have to look at that paper and say how they describe it initially. But if you say typically, that crystalline waterproofing admixture, that's a typical term that they is using a lot around the world.
Okay, no, I appreciate that because I saw some of the papers would say CWA, and I was like, I've never heard anybody
Yeah.
actually say that before.
Yeah.
So it's good. I appreciate that. And
Yeah.
one of the things I was noticing, I was trying to research this because I wanted to be a little bit more knowledgeable. I didn't want to, although I'm not as knowledgeable about these products as I maybe am about some other things. I didn't want to come in here and not know anything. I wanted to be able to ask you some of the right questions. And as I kind of dug in, it seemed to me there were a lot of different types of these waterproofing admixtures, and including the crystalline waterproofing admixtures. They had different chemistries. They created different chemical reactions, and it personally reminded me a lot of colloidal silica. Right now, it's one of the big products that are out there, different colloidal silicas, and they are not all created equally.
Exactly.
It is for sure. And I don't know what you could tell us about the differences in different crystalline waterproofing admixtures. What makes one necessary in a certain instance? What are some of the differences that are out there?
Actually, that's a great question as well because that because so fortunately, when I back to the 2000 again 6 7 when I joined Crichton or before that, in addition that this was weak, it wasn't that much information available about the waterproofing admixture. At that time, I can say the best document was available about the waterproofing was the British Standard 8102 because British Standard talking about the different types of that waterproofing. They call type A, which was membrane system, type B was integral, and type C was cavity. So that's why they divided this way to the three different. And at that time, they used two main terms for waterproofing, or for sure you heard about the waterproofing or damp proofing products. The waterproofing when you're having the more hydrostatic pressure, and the damp proofing, it was a case that the water pressure was lower, mostly about close to the ground or above grade. So, but fortunately, that from at that time, that ACI 212, they start working on the new chapter on the concrete admixture, and they add another chapter they called ACI 212 chapter 15, and chapter 15 talk specifically about the waterproofing admixture. And from that time, they divided the waterproofing admixture to the two main groups. Permeability reducing admixture for hydrostatic pressure, that they call them PRA, and permeability reducing admixture for non-hydrostatic pressure, they call it PRON. And that's a look like a term for waterproofing or damp proofing. That was the first part. But after that, explained further on this part about the chemistry or the material, and it's clearly, I think the best document anybody wants is a look like 2 pages, 3 pages document, but they have lots of good information. And part of that, they explain about this material or permeability reducing admixture in general, PRA, have a different chemistry and they have a different performance. And they showed some of the result of the comparing, the different admixtures, and they showed the different properties. And in addition to that, and they explained, for example, when should I have to use PRA or when should I have to use PRA? So that if your structure is look like below grade and you have a hydrostatic pressure, the product that need to be used for that project should be PRA. And they need to meet the requirement of the PRA. And that is reducing the permeability or just, improving self-sealing and other properties as well. But whenever you are going to use the product that you don't have that much hydrostatic pressure, then you can use PRON admixture. And another section of that document, which is, I can say, nicely explained about which test method should I have to use. For example, if I want to evaluate one product, that this is a product, is a PRA or PRON, then they explain which test method you have to use. Should I have to use the absorption or should I have to use the permeation? That's how they explain. Said, when you have a hydrostatic pressure, you have to use the test method that they simulate the real life of a structure that you have a hydrostatic pressure. But whenever that you want to use a structure that don't have that much hydrostatic pressure, then you have to use the other test that they showing the absorption or capillary, that's absorption in the concrete as well.
So you're talking about being on a bunch of these job sites throughout your career. What are like some of the most common applications that you're working on? Are they water tanks, below grade, like parking garages and downtown structures, bridges? Like what is it that you mostly running into?
Actually, I've been in combination of different projects, but mostly it was it looked like uh, uh, what some of them is look like water tank structures, and some of them look like mainly below grade structures, and some infrastructure project as well. Yeah.
Hey.
Yeah.
Oh man, I feel like I just had a master class on waterproofing concrete. I haven't even let Joey say a word this whole time. The audience might not even realize he's here while we're talking, having this chat. Joey, man, come on in, brother. What do you got for Ollie while we have him?
Did want to ask about your product in relation to like fly ash. I know we headed down to ask you about that. Are one of the reasons that your customers are contacting you guys is because of fly ash issues, be it quality of fly ash degrading or just the availability of it in some areas?
Actually, it's a great question because first of all, I mentioned that part of my research was about the waterproofing, but my thesis was about the permeability of high volume fly ash concrete. So that's why I exposed to the using the fly ash, advantage of the fly ash and limitation of fly ash. And since back to 2003, when I started working on my research. But the point is, that fly ash and other supplementary cementitious material, for sure, you have to consider that they bring lots of benefits to the concrete. That's a reality, especially in the modern mix, that, and whenever you're looking for sustainability, reducing the cement use, from one side, they bring, that advantage. Another part, fly ash and other supplementary cementitious material, they bring some other benefits. For example, they can even reduce the permeability of the concrete. That's another advantage. But another advantage of the fly ash, and as you know, that for example, for ASR, one of the solution that the people they recommend and are using today's a lot is using the fly ash. So, but back to your question, why they recommend to use, that, for example, for the research that we did with the University of Ottawa, they evaluate the possible effects of our product on ASR medication. Said fly ash is already is a solution. Why they are asking using our product in that research as well. So if I want to refer to that one, for sure there is a different reason. First of all, that fly ash and other material look like fly ash. One of them is about some concern about the availability in the future. So that's why, since there's concern, because I remember back to 2002-3 when I wants to present about my research, and I want to list the advantage of supplementary cementitious material. One of the advantage I said cost, because I said mostly this material is cheaper than cement. So that's why one thing they encourage people to use it. It was a cost. But if you look at the many places in the world, because it's a high demand, the cost is not less than cement. I'd say in general, or maybe similar to the cement. So that was one thing. So that's why in the future, maybe the demand for the fly ash and other supplementary cementitious material will be increased. So that's why the supply is less, demand is higher, and they can affect on the cost. Another thing that you have to consider, fly ash and other material like fly ash, they have a different chemistry. So that's why that the effects on the something look like ASR is really depend on the chemistry, because we have a different type of the fly ash. And even if I say type F or type C, even the ratio between their chemical is not different. And some study they has been shown that is really depend on which type of the fly ash that you are using, or what's the chemistry of your fly ash. Your fly ash, they can be enough or they can have some limitation. And some of the recent study that has been done on effects of the fly ash and on the ASR, they shown that fly ash in many cases, they are not mitigate ASR, just the delayed ASR. So, and another limitation that said whenever you have a high reactive aggregate, in many cases, they said fly ash by its own is not enough solution. So that's why they are looking for a solution that along with the fly ash will be used to give the more security to the structure that they are, that they have an active aggregate. So that's why it was a main goal of that research. And that research they shows using our product, which mainly, that I can say the professors and his PhD student that they work on the research, they emphasize a lot on the self-sealing properties because they said this is one of the key benefits of this product. They can enhance that this product effects on the ASR mitigation. And one more thing that I just want to add to your question is back to the first question that the Paul asked about, that when we are talking about the water and we are saying the water, they can cause corrosion, they can cause ASR, they can cause blah, blah, anything. So, and that's a point that, that in one of my research publication, they call it combined mechanism. Because whenever we are looking at the real life, because most of the study at the university that we are testing corrosion or we are testing ASR, we are testing freeze-thaw. But in the real life, the structure, most of the structure, they are not exposed to the one system. They're exposed to the combination of different systems. Look like a structure is exposed to the freeze-thaw, ASR, and corrosion. So there is a more than one mechanism. And in that cases, limitation of the water play a major factors, not only controlling one mechanism, controlling more than one mechanism. Always that typically for me, I give lots of value to the laboratory because they give us lots of good idea, but I give more value to the long-term study. Whenever you are doing the long-term study, it makes us much, much closer to the real life. And I want to refer to one of the, at least I can say, longest studied on the corrosion I have seen that done at the University of Hawaii. And in that study, they make some concrete samples and they expose it to that in the tide zone. And that structure, that sample that has been left for 10 years. So it wasn't 28 days, it wasn't 1 year, it was 10 years. And so whenever, as you know, that's in that tide zone, we have a combination of some, that's because like I said, it's very nice place for the corrosion to happen. And in addition, you have the chloride and you have the other factors that they can, that damage concrete structure. Based on the 10 years study, you can say, I'm really proud to see that when they use the Crichton in that, they perform perfectly, even compared to the lots of corrosion inhibitors. And even compared with some crystalline admixture that has been used in that study. When they look at the control samples, they saw that sign of the crack and corrosion. But when they look at our product, they haven't seen any sign of corrosion or any cracks. So that's regarding to your main question, that regarding to the fly ash and other supplementary cementitious material. I think we have to accept many benefits of the fly ash, but especially for the future, always we have to consider factors. First, which product or system they can be enhanced, even the supplementary cementitious material. And that's something even there has been stated on ACI 212, because they showed even using the fly ash, they can reduce the permeability. But when you combine with the crystalline admixture, even we can see further improvement. And specifically based on the study that has been done at the University of Ottawa, said fly ash is a great solution for ASR if the right type, right amount has been used. But because of the limitation that they stated, that using the plan B, I think is required for future.
Yeah, I do appreciate that you're willing to say the nice things about fly ash, because my previous life I did an unbelievable amount of work with fly ash and would constantly run the expansion tests and all the other durability tests you could ever want to run with both Class C and Class F. And the interesting thing when you're running the ASR tests is you almost absolutely had to have 20% replacement of cement with fly ash to get a positive result. 25% replacement, you could even get better results, but most places at that time when I was doing these tests, 12 years ago or so, there were a lot of places that wouldn't let you use that much fly ash, and now a lot of the fly ash that's coming out are reclaimed sources. So who knows? Hopefully, those chemistries are consistent and reliable. And it was interesting to see because the mechanism, and this is the question I have for you, is like dealing with the mechanism. So the mechanism for fly ash to mitigate ASR expansion is, in order for the ASR to happen, that alkali silica reaction to happen, there has to be soluble alkalis available so that when the water ingresses, the alkalis that are free are solubilizing in that water and then reacting with the siliceous aggregates. You kind of have to have a bit of a perfect storm with reactive aggregates, the ability for the water to ingress, and then the free alkalis. The high percentage meaning 20% and above replacement of fly ash, when you're doing that, it is reactive. Its pozzolanic activity is with the calcium hydroxide that is the free lime that's floating around after cement has done its hydration reaction. And because the fly ash is consuming those free alkalis, you have less alkalis that to later react with their siliceous aggregate. So with that being the defined mechanism for how fly ash mitigates ASR, what is the defined mechanism for the crystalline waterproofing admixtures to mitigate
Yeah,
ASR?
yeah. Actually, that's a great point because that the mechanism that we are doing, that because the fly ash by itself somehow they have some chemical effects on ASR mitigation. Our product, the way that they acting is minimized because for the ASR we need three different requirements. Is one of them is alkalinity, silicate, and the last one is water. And water has two main effects. One of them is a carrier of the water, as for initial, that chemical reaction. And the second effects of the water is more important than the first one because when we have a gel, the gel they absorb the water and they cause internal swelling and internal pressure. So that's internal pressure is a part that they can internally they cause cracking of the concrete, and then we will see on the face of the concrete. So that's why typically we consider uh, ASR and corrosion, both of them. We call it concrete cancer because something happened internally, and then later on you will see the effects on the face of the concrete. So regarding to the way that our product works is mainly works on the third factor, which is water, presence of the water, minimizing the presence of the water, minimizing the presence of the water by crystallization and improving the self-sealing. Then they minimize this third factor and as a result reduce the that negative effects of the ASR on concrete structures.
Good. No, that's good. So that's consistent with the same way that it's inhibiting corrosion of the steel reinforcement. We're talking
Exactly.
about the same mechanism. It's just got a second benefit, and that's mitigation of the reactivity with the aggregates. Joey, I keep hogging all the airtime, brother. Please jump in. Jump in. Take over.
Well, we're getting probably getting close to time, so I wanted to ask before we get out of here, Ali, what's the wildest thing or the craziest thing you've seen on a job site?
Uh, Actually, typically I try to be positive and see everything positive at the job site. When the people they are very safe, they keep safety, they do their job well. So that's a part that makes me happier. But exactly as you mentioned, when you are going to the job site, time to time you will see something. Say, really?
I'm not sure how many of our episodes you've heard, but I think right now the craziest one might be that they were doing a building and it was right next to a hospital, and someone escaped the mental wing, like the mental ward part of the hospital, and they were running naked. A crazy person was running naked through an active job site. So right now, I think that might be in the lead for craziest thing that was seen on a job site. So feel free to try to top that, Ollie.
Honestly, I cannot compete with that on any. But but something I saw for sure is not as crazy as that one, but it look like is just when you see it's really something that you can see. Most of the can say issue I have seen at the job site, especially if I want to look at the waterproofing, is the debris and different thing I saw at the joints. because the joint play that very important factors on having the watertight structure. But unfortunately, in many cases, for example, when they remove the form, you will see the piece of wood or lots of debris, or just some cases, in one cases I saw even, that the Coca-Cola, that it's not advertisement about the Coca-Cola, but the things that people use a lot at the at the job site. But if you can believe or not, in one of the project, even when they put the form, it was ready for placement of the concrete. I saw the hard hat at the joint.
Oh my gosh.
Yes.
Yeah, that's going to cause problems later.
Yes.
Absolutely. So now we've got people who've left their concrete, or I'm sorry, left their hard hat in the farm. We've got crazy people running naked through the job site. Another good one was someone saw them making cylinders and they needed to get the cylinders from where they were making them like over a ditch. And instead of like going the long way and safely carrying the cylinder, they just chucked them over the ditch to the person standing on the other side. These are freshly made cylinders, and they're treating them just absolutely horribly. So I don't even want to know what project that was on or how those breaks came out. But there's some people doing some crazy stuff on job sites, Ollie.
But honestly, I have one more. I don't want to say the source of the place, but in one of the place in the overseas, we went for checking that some of the test has been done in our product. And I saw that the concrete has not been compacted properly. It was very obvious. The curing was completely under a standard, not has been cured. And something we request them to give us some aggregate, to take the aggregate to the central lab and test, that doing another round of the test for checking the properties. But one of the engineer, he wants to ask me some question, and we sit at the office, and they asked other team members to go and take some aggregate. But if you believe or not, I saw that when we went to, get to the car, I saw the people is shoveling the aggregate from the parking area. And I asked them, what are you doing? And they said, we don't have a coarse aggregate, but we use the same coarse aggregate here. And they wants to give us the coarse aggregate was on the parking for months or years. They want to give us that aggregate to take it to the central lab and to test.
Oh my God! It's a miracle that you drove by and saw that.
So honestly, that's something. Unfortunately, fortunately I saw it, but unfortunately, maybe it's happened at some places.
Oh my gosh. Well, Ali, thank you so much for coming on here. We are all smarter having listened to that and learned about waterproofing admixtures. Where can if people want to contact you, what's a good way for them to reach out and find you?
Actually, maybe the easiest way to, that look at my published, that papers and articles. If they ResearchGate, if they searching my name, they will see all of them. And for the easiest way to contact me, alireza@crichton.com. That's the easiest way to reach me. And I'm on LinkedIn as well. If they, that message me on the LinkedIn, I'm more than happy to contact them.
All right, that's great. So that's Ali or Ali Reza Biparva. That's on LinkedIn. His name's going to be in the episode. So you guys just go catch him on LinkedIn. Are you going to be at Concrete Works in Denver this fall?
Unfortunately, no. I am having the 2 trips. Next week I'm going to the Asia Pacific for 3 weeks. Just look like visiting some countries and doing some presentation and seminar. And when I'm back, that unfortunately even I won't be able to attend the ACI because I'm going to the Middle East for visiting 2 countries as well. So
Oh my
unfortunately,
gosh.
I missed some of those. Yeah.
Well, that's a shame because I would have seen you at either one. So hopefully we'll get to meet in person
For
sometime
sure.
soon. I really appreciate you coming on here. Joey, you want to close us out here?
Yeah, Ali, we really appreciate your time today. Like Paul said, we're all smarter because of it, and we'll have to catch you later at some of these other events. Maybe we'll catch you at another ACI convention on down the road when you're not in the Middle East.
For sure. And I want to thank you both. That's for sure, that it was a form of the discussion, and I really enjoyed it as well. And really thank you so much for your time.
Thank you, partner.